Hello student, today we are going to learn an important topics, oxy-acetylene gas cutting. The cutting of iron and steel by using jet of oxygen is extensively used nowadays in industry. Okay, gas or flame cutting is a process by which all ferrous metals can be cut by means of a jet of oxygen gas. It is a chemical process in the sense that the metal at the portion where it is to be cut is actually made to oxidize under the action of flame. Okay, these are useful for straight line cut and also up to a thickness of 40 millimeter. Okay, for thicker plate, when the cut is to be made along specified contour, maybe circular contour, maybe parabolic contour, any type of contour shape, shearing cannot be made. To this end, Oxy-Fuel gas cutting, oxy-acetylene gas cutting is useful. Okay. Now, what is the principle of oxy-acetylene gas cutting? Principle of oxy-acetylene gas cutting. The process consists of preheating the material to be cut to its ignition temperature, that is about 870 degrees centigrade. Ignition temperature means the lowest temperature at which a substance catches fire and undergoes combustion, producing heat and light, is called ignition temperature. Next, when this temperature is attained, then a jet of high pressure oxygen from a special cutting torch is directed on to the hot metal. Okay. The metal then is rapidly oxidized. The molten oxides form in the process. Then this is washed out by the stream of oxygen by the jet of high pressure oxygen. The following chemical equations represent the process. 3Fe plus 2O2 equal to Fe3 O4 plus, this is the oxide, plus huge amount of heat. Okay. Now, what is the speciality of Oxy-Acetylene cutting blowpipe or cutting torch? Here, a special torch or cutting blowpipe is necessary. This is pipe of cutting oxygen. A high pressure jet of oxygen flow through this. It placed at the center. This is the center. This pipe is placed at the center. This is the cutting oxygen. This pipe flow mixture of oxygen and acetylene gas. This is preheating oxygen and this is acetylene gas flow passage. Here mixing is done. This is the flow path. Approximately equal proportion are burned at the small jet. This is the small jet. This is the mixture of oxygen and acetylene gas. The blowpipe, this blowpipe used for this purpose is of special type, which in addition to the usual passage of oxygen and acetylene of a welding blowpipe, in welding blowpipe only this portion are placed, but here carries an additional provision for supplying a strong jet of oxygen. This is additional pipe through the nozzle after the metal has been sufficiently heated. When metal sufficiently heated, then this cutting oxygen is flow. This is controlled by this knob. Okay. When the sufficient heated to red heat. Okay. Now, what is the procedure of Oxy-Acetylene gas cutting? What is the procedure of Oxy-Acetylene gas cutting? This is the Oxy-Fuel gas torch, that means Oxy-Acetylene gas torch. It is a special type of gas torch. This is the metal or workpiece to be cut. This is the cutting line. This is the torch movement. This is torch movement. Here, this is the flame. This is the flame containing molten metal plus metal oxide, iron oxide. This is the width of the cut. For starting the operation, acetylene and the preheating oxygen are turned on and the flame adjusted to neutral. That means oxygen and acetylene amount are same. Okay. After the metal has been heated to red heat, when it is heated to red heat, the cutting oxygen valve, the special pipe, this is the cutting oxygen valve, is operated to make a sharp oxygen jet to strike against the hot metals. This form the iron oxide. This form iron oxide there, and the same get melted immediately. The iron oxide get melted immediately. Okay. It is then washed out. It is then washed out by the oxygen jet. Oxygen jet is flow through the additional pipe, thus providing a narrow cut along the cutting line. Okay. It is necessary to maintain a proper distance, usually about 6 mm, between the nozzle tips and the top surface of the metal plate. Okay. Now, the movement of the blowpipe, should neither be too fast, not too fast, nor too slow. It is not too fast, not too slow. It should be so controlled that it enables the cut to penetrate fully to the metal thickness. Okay. It is clear, my student, the process of oxy-acetylene gas cutting. Okay. Thank you.